Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello, dear students. Welcome back once again to this TV learning series program. As usual, I'm teacher Patrick, and I'll be taking you through a chemistry practical lesson. And a chemistry practical lesson. You remember, last time we talked about the identification of cations. I hope you still remember in the previous series, we were identifying the different cations. This time around, we are not going to repeat the cations, but we are going to do some testing of different ions. So we are going to identify different anions. So we look at the identification of ions. This time we are looking at the anions. And then we also look at the testing for some. We'll have to test for some of the gases. You remember, if I remember very well, also in the previous lesson, we talked about the preparation of chlorine. Theoretically, I hope you still remember. And so today we are also going to prepare chlorine. So we'll look at the preparation. And test. So these are the things that we talked about. If you remember very well, we mentioned a number of tests that we can use for preparing chlorine. The number of methods that we can use to prepare chlorine. If you remember very well, we talked about the reaction between concentrated hydrochloric acid. We have concentrated hydrochloric acid here. So reacting with potassium permanganate, very interesting purple color, potassium permanganate. And then that was one of the methods. So this is what we are going to use to prepare chlorine. But you remember we mentioned some other methods. We mentioned, for example, manganese 4 oxide reacting with concentrated hydrochloric acid. It also gives chlorine gas. Remember we talked about bleaching powder, also reacting with hydrochloric acid. It also gives chlorine gas. Again, we also mentioned the reaction between sodium chloride, that is the table salt, with concentrated hydrochloric acid, or with concentrated sulfuric acid. It also gives hydrogen chloride or hydrochloric acid, which reacts with manganese also to produce manganese 4 oxide, also to produce chlorine gas. So there are several methods that we talked about. And then today, we are going to look at one of the methods for preparing chlorine, and then we test it. So we also look at the preparation of the preparation and test. This is chlorine. So we have the preparation and test for sulfur dioxide. For sulfur dioxide. So those are the gases that we are going to test. But we don't keep the gases in the laboratory for your information. So don't expect me to come with the gases here. So I will prepare them and then at the same time. But the purpose is the preparation, the testing of the gases. And then we'll have to test some other anions as well, as I mentioned in the previous area alone, because we have a number of them. We have chloride ions. We have the sulfite ions. Those are solutions containing those anions. We have lead nitrate, so it will also be used in the testing of those anions. We have the sulfate ions. That is a solution. I've already mentioned this one before. Potassium permanganate. We have lime water. And then we have iodide ions. We have hydrochloric, I mentioned. Then we have barium chloride. water, and then potassium dichromate. This is orange-yellow solution. So we'll be testing a number of anions and then the gases. So without much ado, I think let's go right away, and then we see how we can prepare chlorine and then test it. Please, I ask you to be attentive, because some of the reactions, if you are not attentive, some of the changes may take place very fast and you may not be able to see. So, but I have to make sure I'm protected for precautionary measures as usual, because, you know, the gas we are going to prepare is poisonous. Chlorine is poisonous. So still, I have to put on the nose mask because it is poisonous. You can't inhale this gas continuously. It may bring trouble. So we'll have, this is potassium permanganate, solid. So we're going to use this potassium permanganate. And then we'll have to put it in, so we are preparing chlorine in very small quantities, remember, because it is very poisonous, and we are not preparing it in the gas is supposed to be prepared in fume chamber so that you don't inhale it. But here, we are just going to prepare small quantities, and then we do the testing. I ask you to, please, you need to make an observation of what is happening. So this is the potassium permanganate, crystals. If you can just have a look at them, crystals. And then we'll have to add concentrated hydrochloric acid. Please, your eyes wide, open, so that you can see what is happening. I'm just going to add some few drops of concentrated. As I said earlier, we have to use very little. So if you are very observant, just take a look. There is some, I said I don't want to prepare a lot of it. There is some yellowish color that is seen. Some small greenish color and yellow, it is also coming there. Very little of it, it is there. So that is the color of the chlorine gas, yellowish green. The color is in between. And then we'll have to remember some of the reactions that we talked about. We said chlorine is a breaching agent. Remember what we mentioned? That it is a breaching agent. So we are just going to use litmus paper, the blue litmus paper, and then if you watch very keenly, very close, you'll see some greenish, very pale. It is not, and then yellowish color in there. So we are just going to test for the breaching action. This is a blue litmus paper. And then we'll have to, let me add so that I can produce more gas. The gas is coming. So you may ask yourself, why am I not using my hands? My hands are not very dirty. My hands are not very dirty. So you can see even the greenish color and yellow is still coming. So what am I trying to show here? This was blue. And then you see this color, the red color, is because of the potassium permanganate here. But what I'm trying to show here is the breaching action. This paper, when you look at this one, this was blue. Then it turns red. Immediately when the red color is formed, So you may not be you may not be able to see red because it disappears immediately. You see, it is turning to color, it's turning to white. That is the breaching action. Remember what we mentioned. We said breaching action is removing color from the substance. So this is what happens. Here, we said chlorine. You remember when I was putting the litmus paper, I had to put it in the water here. So chlorine does not breach when it is dry. So it reacts with water, and then it will form the hydrogen chloride, hydrochloric acid, and then the hypochlorous acid. This is hypochlorous acid. So this is commonly known as chlorine water. Chlorine water. So this chlorine water, it was reacting with the litmus paper. So this chlorine water is a very unstable compound, so it easily gives away the oxygen. So when it reacts with the dyes are either oxidizing agents or they are reducing agents. That is the characteristic of all dyes. Oxidizing agents, I repeat, or reducing agents. What does that mean? That they either accept the oxygen or give away the oxygen they have. So this one will give, the dye will accept the oxygen and then forms hydrogen chloride, the dye, and then this is a colorless substance. This is a colorless material. So the dye, this is colored. So the colored material we are using here was the litmus paper because it was blue in color. This is the color of the litmus paper. So it was blue and then turns to the colorless. So when it turns to the colorless, then we are explaining the breaching action. So that is how the breaching action for we have tested. Remember the test that we have carried out. When we are looking at that color of the gas is very important. We said, turns blue, litmus red, and then breaches it. So this is the test for chlorine. So that is how we test the chlorine. So we are able to see the greenish yellow color, and then we are able to see how the color disappears when it is breached by the chlorine gas. So we're just going to proceed and then do some other tests for the chloride ions. So we'll start with the chloride ions. So I think I can just remove this because the chlorine is over. So the chloride ions, we have a solution of chloride ions. When we are testing the chloride ions, we use silver nitrate. Silver nitrate is here. So we have the silver nitrate solution. Silver nitrate decomposes in the presence of sunlight. So that is why you see it is supposed to be colorless, the freshly prepared. So when it is exposed to light, so it decomposes. That is the decomposition. So it decomposes to silver, and then with the nitrate ions. So that is why you see it is not purely colorless, but still, it is still working. So we are going to test for the chloride, the chloride ions. This is an anion. So we said the reagent that we use, so remember, we use silver nitrate solution. Silver nitrate solution. So this is, you can just as well write it in this form. If you are very sure of the formula, there is no problem. But if you are not very sure, please don't write the wrong formula. So you're supposed to write the formulas that are correct, always. And if you are not very sure of the formula, please just write it in Word. There is no harm on that. So we have a solution containing the chloride ions. So as usual, we add some little drops of the chloride ions. That's enough. These chloride ions are coming from any solution, any soluble salt of the chloride, sodium chloride, sodium nitrate, potassium chloride, and all those. So you can still have the chloride ions. So we are going to add silver nitrate, some few drops of it. Oh, I've just added even a lot, but still it is there. Just look at it. White precipitate. The white precipitate is formed. So let me see whether if I add excess, what happens? That is the excess. So what happens? The silver ions, these silver ions are coming from the silver nitrate ions. That's why we put a solution. When we say aqueous, that is a solution. And then we add, they are reacting with the chloride ions. When it reacts with the chloride ions, then it will form silver chloride. Silver chloride. So the silver chloride is this white precipitate. This one here, it is this white precipitate. So let's look at the silver, instead of the silver ions, we can even take advantage and also look at the ions of the group 7. So we have the iodide ions here with me. So the same reagent, so we can take an advantage and then look at the test for the iodide ions because they use the same reagent. That's why we are taking advantage of the silver nitrate present, and then we can still even test for the iodide ions. So we have the iodide ions here. Just take very little of it. Don't need a lot. A little solution of the silver iodide, of the iodide ions. And then very little of it. That's enough. This is a colorless solution. We are also going to add in this solution, we are adding chloride ions. So the chloride ions, no, the silver nitrate, sorry. So the silver nitrate is here. So this is the silver nitrate, some few drops. First. Oh. Excess. All right. So this is the color. Pearl yellow. When you look at it very closely, there's some yellow color in it. It is pale yellow, and it is a precipitate because it doesn't dissolve in excess. So we have the same reagent. We're having the silver ions reacting with the iodide ions in this solution, and then forming silver iodide. So this pale yellow solution is the silver iodide here. So this is the pale yellow solution that we are just seeing right now. So if you look at this one, maybe something else I can mention is that these ions, if silver chloride is added in excess of the ammonia, the silver chloride is then added in excess of ammonia, the precipitate is supposed to disappear. This is for maybe the A level. You can just be attentive here. So this one forms, silver chloride is a very sparingly soluble salt. So it exists in equilibrium with the silver ions and the chloride ions. So when you add ammonia solution, the ammonia solution combines with the silver ions and then forms diamine silver ions. This is a complex compound. What happens here is that this equilibrium will be destabilized. Formation of complexes, I'm just talking to A levels now this time around, maybe not very important but you'll still come there. So here, the silver ions are removed by the ammonium ion, the ammonia solution to form this complex. And if these ions are removed from the equilibrium will no longer be stable. That is according to the Le Chatelier's principle, that removal of this one, that is reducing the concentration. So that means the equilibrium will have to shift to repress this ammonium, the silver ions. That is why this one dissolves in excess ammonia. So formation of complexes increases the solubility of sparingly soluble salts. So we can look at the test. Remember what I mentioned, that we are done with this. So we are going to look at this one, the sulfur dioxide as well. So the sulfur dioxide, so there are a number of tests that we'll have to carry out. Sulfur dioxide is also prepared from different methods. The senior theories, probably you still remember that, because this is just a revision. So a number of methods, but basically there are mainly two. When copper combines with concentrated sulfuric acid. So we have some tests that the reactions. Copper reacting with concentrated sulfuric acid gives, this is copper sulfate plus sulfur dioxide gas and plus the water. This is the first method. We have another method where we have, remember, what happens with this preparation, that the acid must be concentrated because copper cannot disperse this, the hydrogen. It is less reactive. So that's why the acid has to be concentrated. There are conditions, and therefore there must be even heating. If those conditions are not fulfilled, then you'll not be able to produce the gas. Then we have also sodium sulfite. Sodium sulfite reacting with the hydrochloric acid. So this will give the sodium chloride plus sulfur dioxide, and then water. These are gases being produced. So this time we are just going to use only the second method. This second method is the one we are just going to use to prepare the sulfur dioxide. So we'll need the sodium sulfite here, but we need to test the gas as well at the same time. Sulfur dioxide, I hope you remember its physical properties. It is also produces unpleasant, it is also irritating, like chlorine, with the unpleasant smell. So choking, so it attacks even the lungs. So we have to prepare as we are protected as well. So we're going to prepare that sodium sulfite. So we have the sulfite, the sodium sulfite here. We do the test. So we'll have the test here. We'll add some more. This is sodium sulfite. very white crystals. I think that's enough. So we have to add in this hydrochloric acid. It can be concentrated or can be dilute, no problem. The reaction still goes on. But if it is concentrated, then the reaction goes very fast. So we'll have to add hydrochloric acid. And then at the same time, we have to test it with the litmus paper. So I have some litmus papers here with me. So I have to use them to test the gas. This is a blue litmus paper. So I have to add also a solution of concentrated hydrochloric. You can see what is happening down. Maybe let me just put it down a bit so that you can see it properly. Sorry. So, and why am I avoiding to use my hands? My hands may be even acidic, so that's why I avoid to use the hands. So when you look at the gas, you see some bubbles. That is what we call effervescence. So the gas is also coming, but it is coming slowly. So I can as well leave it there. See what happens. You see it turns red. It turns red. I can as well add more acid so that we have more gas coming. Some few bubbles of the gas. Very small bubbles of the gas, so we'll have to be patient maybe for some few minutes. And then, so if the gas reduces a bit, but we have seen the litmus turning from blue, this is the blue litmus paper, so it is turning from blue to red. What would happen next that we're supposed to get? So the litmus paper is turning to red. So we can increase even the concentration of the amount of the gas by adding more the sulfite, so that the gas continues to come. Why do we have to do this? So we can use another litmus paper, no problem. So I have to increase turning red already. Right now we're just going to look at the test for sulfur dioxide, because we have mentioned we have to prepare sulfur dioxide and then test it. So this is how we are going to test. Remember, I mentioned that we have to use sodium sulfite, and then we'll have to react it with the hydrochloric acid. So one of the reagents that we use is this potassium dichromate. It is orange-yellow solution. So I urge you to pay attention and see what is going to happen. So we're going to put hydrochloric acid here, and then we pass this gas into this solution to potassium dichromate, and then we add hydrochloric acid in this one. Then we see what happens with the please observe what happens there. You need to make an observation, very clear observation. You see what is happening? See what is happening? The gas is coming. Let me add once more one of the acids so that we can produce more gas. So that's it. I think you can see what has happened. What color is this one? That is this one turning to green, so I can just remove it. And then I'll just show it to you properly. This is turning to green. When you look at it properly there's a green color, which is there. So let's try another one. So we can still use potassium permanganate solution. Potassium permanganate solution. And then we pass the gas as well in there. So we are going to add it. We also pass the gas, so we have to prepare it once again. And then add this is the sulfite again, as we mentioned. So we're going to prepare the gas and then pass the gas in here like this. This is just a kind of improvisation that we've tried to come up with. And then we get the gas. Wow, so I think you have seen what happens. So the color of this one, the potassium permanganate, this is the potassium permanganate turned colorless. So those are the two reagents that we can use to test for sulfur dioxide. So we have potassium dichromate. This is yellow-orange, and it turned to green. So we had potassium permanganate. This is purple, and it turned to colorless. So those are the two tests that we have done with sulfur dioxide. Remember, I said we have to prepare the gas and then test it. So those are the two tests. Please, I'll just leave before I just wind up. I just want to show you the exercise, so you'll do the exercise, and then I hope you'll meet again. And I believe probably it has been wonderful, because for me, I'm satisfied. So I believe as well that you've been also satisfied with what we have done together. Hope to see you again next time. If you have questions, please forward them to your teachers. Thank you for watching and listening. Bye-bye.